In this episode, we're going to look at how to propagate a default route in OSPF version 2. I'll show you how to do it, and we'll talk about the concepts along the way. We will configure an IPv4 default route to the internet and propagate that default route to other OSPF routers. We'll then verify the default route is in downstream routing tables and that host can now access a web server on the internet. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 2.5.3, propagate a default route in OSPF version 2. I have a Packet Tracer Lab open up. On the left side, we have our work area, we have our topology, all of our devices that we're going to configure. On the right side, I have our instructions. The way bottom right, I have the Packet Tracer activity window that opens up when I open up the Packet Tracer file. That's the normal one. It has all the instructions in there. On the top right, which is the main area on the right side, this is the Word document of those same instructions. Reason I have the Word document is there's some questions we need to answer. With the Word document, I can type my answers in and I can save that document then. Here on the left side, we have 3 routers configured sort of as our core. These 3 routers each have a LAN coming off of them. And then we do have an internet connection coming off on the upper right. We have our addressing table with all the addressing informations for the devices, the interfaces, the IP version 4 address, subnet mask, and default gateways where appropriate. Part 1, propagate a default route. Step 1, test connectivity to the web server. From PC 1, 2, and 3, attempt to ping the web server IP address of 64.100.1.2. Were any of the pings successful? So from each PC, I need to ping our web server. Open up PC 1. Click on our desktop tab, and then click on the command prompt. From here, we can go ahead and ping that web server. So ping space 64.100.1.2. Destination unreachable. 172.16.1.1 says destination unreachable. When we look here, 172.16.1.1, let's go up to our addressing table. 172.16.1.1 is the gigabit Ethernet face on router 1, which happens to be PC1's default gateway. So what that's saying is PC1 can make it to R1, but then R1 doesn't know how to make it to its destination. So it's saying destination host unreachable. So we are able to send out an echo request. R1 received it, but couldn't get it to its destination. So it's replying back, I can't reach the destination. Okay, so PC1 doesn't work. Let's go ahead and try PC2. Desktop tab, click on the command prompt app. Go ahead and type in ping space 64.100.1.2. Destination host unreachable. Same thing happened, but now it's a different address. We're on a different PC. 172.16.2.1, that happens to be the default gateway for PC2. If we look in the addressing table right here, we can see that is our default gateway, 172.16.2.1. I hope you're liking this episode on practical configuration examples. Leave a comment on what you think about these configuration examples. If you still have a question or comment, please let me know below. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. That's our default gateway. In our default gateway, we were able to send an echo request from PC2 to our default gateway, R2. But then R2 wasn't able to reach the destination at all, so it sent back a response. So yes, we did send out a reply. We did get a response back, but that response was, hey, I couldn't reach the destination, so it wasn't successful. Let's go ahead and look at PC3 and try and ping the web server. On the desktop tab, I'm going to go ahead and click on the command prompt app here. Type in ping space 64.100.1.2 is the IP address of our web server. and we are getting the destination host unreachable again. Same thing is happening. The default gateway is able to get an echo request, but not deliver it to its destination. So we're able to reach the routers, but then the routers don't know how to get to this network where the web server's at. Were any of the pings successful? No, they weren't. What message did you receive and which device issued the message? Destination unreachable. Message we received was destination host or destination unreachable. So destination unreachable. And who sent that? Our default gateways. Examine the routing tables on R1, R2, and R3. What statement is present in the routing tables that indicates the pings to the web server will fail? So what statement? Let's go ahead and take a look at R1. Click on our My CLI tab, make this a little bit bigger, right to left. Hit enter, type in enable to get us into privilege exec mode. Now, here's a prime example. I typed in enable, I typed it wrong, I spelt it wrong. The operating system did not recognize it as a term, so it's assuming it's a name to translate into into an IP address. They're going to do a domain server lookup on it. Seeing as I don't have a domain server set up on my network or define, we have to go and wait for it to time out. To get rid of this, this would be the no IP domain lookup, where if you type in a command wrong, instead of trying to resolve it like we're doing right now, it would just go ahead and say, nope, that command was wrong. And so we have to wait for that to finish airing out. We're going to wait here, wait for a little bit, wait and wait and wait. Still got to wait. It's the longest, like 15 seconds of your life, especially when everybody's watching me on a video. Now let's go ahead and type enable correctly this time. We are into privilege exec mode. Now, look at the routing tables. To see the routing tables, show IP route. Looking here, we have our codes. Right here it says gateway of last resort is not set. And then we have, for all of our directly connected networks, a CNL directly connected for our network. And then the local IP address of that interface. We have one, we have a second one, we have a third one. And then we have a couple networks we learned through OSPF. Well, they're listed right there. But the big thing, and I hit spacebar, and here was another network too we learned through OSPF. The big thing here is the gateway of last resort is not set. Once again, when it gets a packet in for a destination network, PC1 is going to send a ping here, an echo request to R1. R1 is going to look through its routing tables. Does anything match in here? Nope, 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 nope. Nothing matches. When nothing matches, it then goes and says, is my gateway of last resort set? If it is, we're going to send it there. What's going to happen is we're going to set the gateway of last resort to R2 or something else. And then when we send that information there, hopefully that device can handle pushing that on. So gateway of last resort is not set on R1. Let's go ahead and look at R2 quickly. See if that happens to be the same case. Make it a little bit wider, going left to right. CLI, type in enable. Show IP route. We have our gateway of last resort is not set again. Go ahead and check R3. See if that's also a problem over here. Config. Okay, click on R3 again. Click on CLI. Type in enable. And then show IP route. Gateway of last resort is not set. So what statement is present that indicates the pings to the web server won't fail? Gate gateway of last resort is not set. Spell gateway correctly. Takes care of part 1, step 1. On to step 2. Configure R2 with a directly attached default route to the internet. So on R2, we're going to configure that. R2, we're going to go ahead and set our gateway of last resort. We need to be in global configuration mode, so I go ahead and type config T, and then the command here is just like setting a static IP route. We start off with IP and then route, and then we want to take all traffic. After we processed every line in that routing table, we're going to take all traffic and push it towards another device. To do that, we use our quad zeros. We're going to take all IP addresses, regardless of what they are. We're not going to match anything, and we're just going to pass it on. So we put in 2 quad zeros. First quad zero here is for the network portion, and then the second part is for our subnet mask. So our network address and our subnet mask. And then we want to have a directly attached, meaning we want the interface. And R2, we want to push it towards the web server. So what I'm going to do is I'm going to click in this window. We want it to go out this connection. I'm going to mouse over this green triangle, and it's going to say we need to push it out serial 010. And our exit interface is serial 0/1/0. Gives us a warning. Without a gateway, we're going to have a problem, but that's fine. It's just a warning. Now we have to propagate that through the entire OSPF network. We set it on R2, but now we're going to set it and propagate it through using OSPF to say that the gateway of last resort is this connection right here, and we're going to use OSPF to do that. Otherwise, you'd have to go around to each device and manually enter that in. Now, to do that on R2, we have to go into our routing configuration. So our command here is router space OSPF, and then we put in our process ID. Our process ID is 10. From here, we can say, okay, now we have a designated router, our default route, the gateway of last resort set on this device. Let's go ahead and propagate that out. We're going to originate it from here. And so we can say default -information, and then we can say originate. And so that way we're going to originate from here and push it out to all of our other devices. Default information originate. I did screw up something. Notice here I have OSPF 10, but we are actually using a process ID of OSPF 1. So I set default information originate on the wrong process ID. So I may have 2 processes running for OSPF on my router. That's an advanced topic, not necessarily covered in this course. But what we can do to fix this is go back into the correct process. So I can go ahead and type in router OSPF 1. And then I can go ahead and type default -information space originate. And that'll propagate it out correctly through OSPF. Go ahead and type exit. I'm going to minimize that. Examine the routing tables on R1 and R3 to verify that the route has been propagated. So let's go ahead on R1. And let's type in show IP route. And look at this. We now have a gateway of last resort is the IP address up here. It's an IP address on R2. If that information makes it to R2, then R2 pushes it out this interface. But it says gateway of last resort is 172.16.3.2, which is this interface right here, to network 000, meaning anything. If it didn't match any of the statements in my route statement, it's going to take what remains, we don't care what it is, and we're going to push it towards the router that has 172.13.2 as an IP address. So our gateway of last resort is set, and we set that through OSPF. Let's go ahead and check R3 quickly. So R3, and the command here was show IP route. And here is our gateway of last resort. It was set. Gateway of last resort is 192.168.10.9. That's on this network that's connected between 3 and 2. That's this IP address right here. So any information that doesn't match a routing table, we're going to push up here to R2. Then R2 has the default route that pushes it out this interface. That'll make it to the internet. Now, how can we verify that we did learn it through OSPF? That's what this little asterisk is down here. So the code here says we learned this through OSPF, but then this asterisk right here signifies that it's a candidate for the default route. That's where we learn our default route from. Part 2 is we're going to verify connectivity, verify that PC 1, 2, and 3 can ping the web server. So open up PC1 here. It's the same command. I'm just going to hit up arrow. And we're going to try pinging it. Hopefully we're doing ARP requests. That looks like what it did. Failed the first one. Next 3 worked. I'm going to just simply repeat that. Up arrow once. Hit enter. All 4 are going to work. We have full connectivity to the web server. Let's go ahead and try PC2. PC2. Up arrow. We have full connectivity to our web server. And then PC3. Repeat the ping to the web server. All 4 works. PC3 to the web server. That was Packet Tracer Lab 2.5.3. Propagate a default route in OSPF version 2. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.